Alright, today we're going to work on activity 4.2, building the cone volume formula, as well as trying to get to activity 4.3. Both of these seem to be really short. And then I have a worksheet assignment for you guys that work on cylinders and square pyramid formulas. So on here it says you have learned that the formula for the volume of a cone, like the formula for the volume of a pyramid, is, I'm going to highlight it, V equals 1/3 base times height. Okay, so that's what is highlighted in green. Okay, that's annotating standard 1.1. You can use Carovelli's principle to understand why the volume formulas for the two different solids are the same. Consider the cone and pyramid shown. Their bases have equal area. Now, number one, if the length of the radius of the base of the cone is r, what is the area of its base? So if we look at this, we can look and find out what the area of the base is by seeing that this is a circle. Okay, I'm going to put it in a bright pink, that we can see that this is a circle, is that shape of the base. Okay, we should know the area of that right away is area equals pi r squared. Okay, that's how we find the area of a circle. So pi r squared. That's your answer. If the side length of the base of the square pyramid is s, what is the area of its base? We talked about this before, where if s is represented for the side, which is shows right here, area equals side squared, because it's the side being times by itself twice. So side squared is your answer. So just so you know, this is an S, not a 5, an S. You are given that the areas of the bases are equal. Set the areas equal to one another, to each other, and rewrite the equation in terms of the side length of the base of the side pyramid. So essentially, all I'm doing this is S squared is equal to pi r squared. Okay. Now, I'm trying to get it to be everything, trying to reduce it down as best I can. Okay, so to do this, we have to square root both sides to get rid of the 2. So doing so is going to eliminate the 2 on the S, and it's going to eliminate the 2 on the R. The difference now is the R comes out, the square root sign stays, because pi does not have a 2 attached, so we can't reduce that. But the r we could, because there was a root 2. Okay, so our final answer just looks like this. All right, because that square root is taking away the 2 and the r, as I said, but it cannot take anything away from the pi, so the pi has to stay underneath the square root. All right, let's look at this next page, work sample. You can use similar triangles to show that the area of the cross sections are equal. The cross sections, just so people know, are what the shaded area is. It says write an equation for the length of the radius of the cross sections of the cone. Excuse me. So we zoom in. They have their writing here. They have k over h. So k is the height here. And h is right here, so kind of like the shadow formulas we've done before. Then they have x over r, which x is right there, and r is right over there. And they also have kr, so I'm going to kind of do another color, kr over h is equal to x. Okay, so going through their formula, they have some stuff here. They can substitute kind of some of the stuff we've done. If we look at number 4, use Carovelli's principle to explain how the worked example shows that the volume of the cone equals the volume of the square pyramid. We're going to skip these because these... actually, we can just skip 4. 5 we can do. it's asking us explain how you know that the formula for the volume of a cone is V equals 1/3 base times height. So we can sit here and say that this, because the volume of a cone is the same as a squared pyramid then the formula for the cone is the same as squared pyramid. So essentially what that means is that because we know that the volume of a cone is the same as a square pyramid, we can use the same formula. We don't have to change formula. So the nice thing for a square pyramid and a volume of a square pyramid and volume of a cone, we use the same formula. So you only have to remember this one formula for those two. Okay. Now we're going to work on 4.3 today as well. Because it is only this page, and then we'll do 4.4 tomorrow because I have a worksheet that you guys are going to be doing that kind of continues on some of the work we've done. Now, let's investigate the volume of two different cylinders created with a standard size sheet of paper. I'm not going to have you guys create this because some of you may not have the material. So let's actually see. We're going to actually skip this, so we'll skip 4.3 just because they're having you do this on your own on a separate sheet of paper. And in case you guys don't have it or understand how to make it, we're going to come back and do this later if we need to review when we return to school. So let's just go to 4.4, and then we'll be done with that. We'll get through part of 4.4, and then we'll finish 4.4 tomorrow. So it says surface area. In the previous activity, you explored a different volume created by rolling a piece of paper in two different ways. The cylinders that you created had the same lateral surface area. The lateral surface area of a three-dimensional figure is the sum of the areas of its lateral faces. The total surface area of a three-dimensional figure is the sum of the areas of its bases and lateral faces. Now it's telling us to consider that right cylinder shown, so over here on the right side. Sketch the base and lateral faces of the cylinder, including the dimensions. So, to do this, we have to look at this as a two-dimensional shape. Okay? So the first one, as a base, we can look at the base, which is the shaded in the top. Those should be circles. So we just draw a circle with a line coming from the middle to the edge, like that, with an R because that's our radius. Okay, so this is our base right here. Our two bases that we have. Okay, as I said, you just draw a line. It doesn't have to be dead perfect center. Do the best you can to get in the middle. That is our base. So these are our bases. Our lateral face. So I wish I was in person to be able to show you guys this. But if you hold your iPad up face-wise, and I know my screen just shifted, sorry. If you hold it up face-wise and then you spin it around, if you had this taking a pencil around the edge, it'll make a cylinder, a three-dimensional shape of a cylinder. So our lateral face is going to be a rectangle, okay? Because obviously, if it was a square spinning, it can still work, but a better cylinder is a little taller than it is wide. So if you spin this, it shows a little bit better for you. So a lateral face is this. And the properties, as we've talked about before, is height, which is the h. And then because we're going in circle, it's going to be 2 pi r. Now, part B is asking us to determine the area of each face. Okay, so the area bases. So I'm going to write 1 here, bases. I'm going to put this as 1 and 2. They're both going to be pi r squared because those are circles. So pi r squared and pi r squared, comma pi r squared. Both of those are circles. Now, for the lateral face, I'm just going to put LF for lateral face, abbreviated for you guys. We just multiply these. So all the easy way to do this is you just rewrite it as 2 pi r h, because we do not have number values for the h or the r right now. So you just write them like this, and essentially what that means is 2 times pi times whatever the radius is times the height. Okay, so just make sure you guys understand that when they're next to each other like this, they're always going to be multiplying. So that's all you have to write for that one. Now, use your sketch to write the formulas for the total surface area and lateral surface area of the cylinder. Explain your reasoning. So total surface area. So I'm going to write total SA, and then lateral surface area, because we have to have the 2, they say. So once again, make sure you, when you read directions, they're telling us to have the total surface area and the lateral surface area. Keyword here is and. If you only do one of them, you will only get partial credit. So the way they have us writing these out is essentially the lateral surface area is just going to be the same as up above here. This just drops down. So 2 pi r h. Our total surface area ends up being, because there's 2 of these, it's going to be 2 pi r squared h plus 2 pi r h. So the way they get this is they use our total surface area, so it's the overall, so we're doing 2 of these, 2 circles, whereas how they get this, I'm going to actually not do it that way, I'm going to highlight it, that's how they get this, and then they have to drop the lateral because you're talking about the height of the shape that's spinning is how they get that part right there. Okay, so that's the total surface area, so they're talking about both of these shapes. They're all 3 of the shapes. Now, we're going to finish up on 2A and B, and then we will call it a day, and you guys have a worksheet that you should be working on and submitting when you are finished with that today. So do not forget to submit. I will show you guys once again how to do it on this video so that you guys are turning your work in, because I have not been getting work right now. So make sure you turn your assignments in, or at least email it to me so that I have it. So it says a cylinder paint roller has a diameter of 2.5 inches and a length of 10 inches. So let's look at this way. Okay. Actually, I'm going to redraw this to make it look a little bit better. So they're talking about a paint roller. For those of you guys who do not know what a paint roller is, I'm going to put lines like this so you see that goes behind. Paint roller is essentially what you use to help paint a... Actually, here, I'll draw this actually more in the way that's supposed to be. But a paint roller is what helps you paint in your house. So they're more shaped long like this. Ah, well, that's fun to change that on me. Where it's shaped long like this, and you attach it onto a brush that helps it roll on the paint. So they're saying that the diameter is 2.5. Now remember, we need to find the radius. So diameter is 2 of the radius. So we have to take 2.5 divided by 2, which ends up giving us 1.25 as our radius. Okay. Now we have to use these formulas and plug in the numbers. So we already know our height is 10, or our length is 10 inches. So it's still a height. They're just having it on the side. Okay. So now we just plug in these numbers. So 2 pi parentheses 1.25 squared times 10 plus 2 pi 1 parentheses 1.25 close parentheses again 10 because you're multiplying like that. Now, oh, I'm sorry, I put the wrong formula for this one. Please erase that. I'll write the correct one. I accidentally flipped them around. So this one's just going to be, they're talking about the lateral surface here area, and there's going to be 2 pi times 1.25 parentheses again, and 10. And you type this in your calculator. I'm doing it on my calculator right here. Make sure you use the calculator app on your computer, or on your iPad, not your phone, because it will not give you an accurate number. Okay, because we're using the exact pi number. We're not just adding pi in at the end. So when you type it in, do 2 alpha, or I'm sorry, not alpha, second, the caret key gives you the pi symbol, parentheses 0.1 or parentheses 1.25, close parentheses again, type in 10. When you hit enter, it should come out to be a number of 78.539, and we're going to round up the 9 to be a 0 and make the 3 a 4. So our answer should be this, 78.54 squared. And they're using the measurement of inches here, they say. So we have to write squared inches. And that is our answer. Now they're asking us to do the total surface area. So now we just do the formula I originally had, where it's 2 pi parentheses 1.25 parentheses squared times 10 plus 2 pi parentheses 1.25 parentheses 10. Now, this last part here, we already know the answer. We can bring this down as 78.54 because that's what we did in the part above. So now we just do this, the first part in our calculator, which is, once again, 2 second, the caret key above division, gives you the pi symbol, parentheses 1.25, close parentheses. Either A, you can hit the caret key, which is above the division, and hit 2, which gives you a square root sign, or just kitty corner to number 7, there's an X with a 2 in the upper right corner. You can hit that, and that will give you a squared as well. Just make sure you hit the right arrow to move over, that you know it's done, and that you can type in the next part. Then you hit parentheses 10, close parentheses, press enter, and it gives you 98.174, and now we just add 78.54 to that, and our answer comes out to be 176.71, because the last number is a 0.714. 4 is not higher than 5, so we have to round it down. And we just write squared inches. And that is your final answer. Okay, because like I said, we got this down to 98.174. And that is your final answer. All right, now I am going to show you guys how to submit this. It's going to be a little different on mine, but essentially you're hitting the same buttons. It just mine will not show the student submit. To submit assignments, you have to hit this key right up here in the top corner. That's a square with an arrow. You go down to other apps. You hit share note. This should be in a PDF. Share note. It's working to make the assignment be shareable. You would hit student. Once you hit student, it comes up. You have to make sure you are in the right class here. If you don't submit it to the right class, so you have to hit your classes right here. Course. Hit the course. Find the class. You are Math 2. Okay, click Math 2. Make sure it's under the right assignment date. Okay, so whatever the assignment's called, when we're finished with all this, submit it, especially the worksheet that we're doing today. So there's a worksheet that I just added this morning, and it's called volume of square triangles. So when you submit the work for that one, you have to find volume of square triangles, which is all the way down here at the bottom. You would click that and then submit. Make sure you are submitting to the right class and what the right assignment is, so I can give you guys a grade on that. Reminder that Tuesday we'll be doing a Zoom meeting. It's just a check-in, see how you guys are doing, if there's any questions, and we'll go from there. I'm going to be planning a Zoom meeting once a week, just checking in until we return to school. If you guys have any questions, as always, please shoot me an email. Email is spitts@rlas-116.org. I hope to see you guys soon. Like I said, if you got questions, please do not hesitate to reach out. Talk to you guys soon.